Welcome back. So now to jump into our first concept, as we've said, we're going to be looking at the metal oxides and how they react with acid. So to begin, we should know that the reaction between a metal and oxygen produces a metal oxide. So whenever we take a metal, remember metals, they are found, we can find them, they are categorized in the periodic table in terms of them being metals, non-metals, and also the metalloids. So the metals, when a metal reacts with oxygen, we're going to get our metal oxide as the product. So metal oxide is now the combination or the reaction between metal and an oxygen. The pH of metal oxide can be tested once it is dissolved in water. Because in most cases our metals are solids, we cannot really test or check if whether that metal oxide is acidic or basic. We need to dissolve it in water first so that we can test the solution if whether the solution is acidic or basic. And remember, to test the solution, we're going to be using indicators. Indicators, they are helping us to determine if whether the substance is acidic or basic. We have different types of indicators. In this, we can also use the blue litmus paper, the methyl orange. There's a lot of them that we can use to test if whether a substance is acidic or basic. So, the pH of a metal oxide, once dissolved in water, will be above 7. Now, you should know that if something has a pH that is above 7, it's going to be basic, regardless of whether it's a strong base or a weak base, but it's still a basic solution. So now, that tells us that now our metal oxides, they are bases. Whenever they dissolve in water, once we test them, we find that they are bases because they have a pH that is above 7. So when it dissolves in water, it can be reacted with an acid according to this equation. So now after we have dissolved our metal oxide into water, and we find that the solution of that particular reaction is going to be basic, we can react now that basic solution with the acid. And remember, once the base reacts with an acid, the product is going to be salt and water. So when an acid that you're talking about here reacts with the metal oxide that we have dissolved in water, the product is going to be salt and water. So those are going to be our two products. So we do know what water is, but then now what about salt that is always going to be produced when we are reacting an acid and a base? What do we mean by that? So now the term salt, it is used for a variety of neutral substances that contain a metal and one or more non-metal elements. So our salt, it is going to be, it's a variety of neutral substances. Remember, for us to be able to have the neutral substance, it means the acid, the neutral substance being salt. The acid that reacted and the base that reacted, they have to have had the same or more or less the same range of the strength in terms of them being acidic or basic. Now, we are saying that the term salt is used for a variety of neutral substances that contain a metal and one or more non-metal. So the chemical formula for salt will contain a metal and sometimes one or even more metal and non-metal elements within one chemical formula of a salt. So all salts can be produced from the reaction between an acid and a base. For an example, so we're saying that salt is going to be produced when we are reacting an acid and a base. For an example, we can have this salt table, our table salt, the one that we normally use, which is our sodium chloride. So we notice that the sodium, it's the metal part that they were referring to. And the chlorine, that's now the non-metal part that they were referring to. So again, we can have the potassium chloride, where the potassium is your metal and the chlorine is going to be your non-metal. Same thing applies to the sodium nitrate. The sodium is your metal and the nitrate is going to be our non-metal. So now, we need to know that for them to produce, or for these salts to be produced, what were they using in order to produce the salts? Remember, we're saying that an acid is going to donate a hydrogen, whereas the base is going to donate the hydroxide. So when that happens, there's going to be water being produced from the hydrogen and the hydroxide. Then the remainder is going to be salt, right? So now, a typical example of the reaction between a metal oxide and an acid would be, so we have a typical example here that we can use to better explain what is going to happen between the acid and the base when they react. How is the salt going to be formed? And where do we get the water from that you're talking about when looking at this particular reaction here? So we have a nitric acid We also have the calcium oxide as our metal oxide, and then the salt that is produced there is going to be our calcium nitrate. And then lastly, we have water. So our acid, our base, our salt, and water. As we have said, acid plus base gives us salt and water. So therefore, we're saying that the acid, which is this is our base, and that's our salt, and then obviously our water. So we are saying that the acid is going to contribute a hydrogen, the H atom, whereas now the metal oxide is going to now contribute the oxygen. Then now when those two things are going to react together, they're going to form the water molecule. But then we do know that for us to have water, we need to have 2 hydrogens, and for every 2 hydrogens that we have, we must have 1 atom of oxygen. So where do we get that? We are going to now make sure that our equation is balanced so that we can be able to get the H2 and the H2 on the left-hand side and also on the right-hand side. The number of atoms on either side, they need to balance. They need to be exactly the same so that we can have a balanced equation. And we also said that once the hydrogen has been contributed by the acid, and the oxygen in this case, or the OH when you're looking at the hydroxide has been contributed by the base, the remainder becomes the salt. So in this case, once the nitric acid has contributed the hydrogen and the calcium oxide has contributed to the oxygen to form the water, the remainder is going to be our salt, which is going to be the calcium, which we're finding it there, and then the nitrate, which we find there, the nitrate. Now, we need to know that on any chemical formula that we have subscripts and coefficients. So the subscripts are telling us the numbers here at the bottom, they are telling us how many of those particular atoms we have in this compound. Whereas the 2 that is in front, the coefficient, is used to balance the chemical equation. It tells us how many molecules of that particular compound. This tells us how many atoms in that compound do we have, and then this tells us how many molecules of this compound do we need or do we have. So we said that the remainder of the acid and the base combine to form the salt, which is our calcium nitrate. And then the metal part of the salt comes from the oxide, being the calcium, and the non-metal part comes from the acid, that's being the nitrate. So we have our calcium and the nitrate coming from 2 different substances to form the salt. So the reaction equation is balanced when we say, again, remember, when we said 2 molecules of nitric acid react with 1 molecule of calcium oxide. So the 2 molecules that they're referring to is the 2 here. And we do know once we don't see any number in front of a chemical compound, the number is 1 there, because we're saying that for every 1 mole of this, or for every 1 molecule of this is what is going to be happening. So there's a 1 there. So we're saying that when 2 molecules of nitric acid react with 1 molecule, the 1 is the 1 there. 1 molecule of calcium oxide, then we can say that this reaction this equation is balanced. So to move on to our next concept, that's now when looking at the non-metal oxide when they are reacting with the acid. We're just going to quickly go for a short break before we go into our non-metal oxide and the acid. Go for a short break and I'll see you just after this.